Thanks, everybody. So I'm going to get this out of the way right first. So I wrote a book, and I'm like totally promoting it, and I'm, I don't know, not very ashamed about that at all. I want to give away some books. I brought some, and I want to give them to you. So if you are using the Twitters, share something that you learned during this session, any of the talks during this session. Tag it with the SATURN 18, and if you want to be considered, also tag it with Design It, so I know to look for you in that. There's also a discount code if you don't win, but you know, such is life, I guess. All right, let's get to it. Hi, my name is Michael Keeling, and I'm going to talk to you today about managing your technical debt portfolio. Congratulations, everyone. Great work. We finished it. It shipped. No sooner had the perspiration, dried on our glasses when our product owner showed up. All right, everybody, time to get started on the next big features. All right, let's do this. New features. It's going to be amazing, right? Well, the code's a little messier than I remember. We can still do this, maybe, right? Okay, who did this? This is terrible. Perhaps you've experienced this range of emotions as well, reviewing things, only to find out that the enemy is ourselves, and we made this awful mess. Not only did we make the mess, but we actually did it on purpose. So we had shipped on time, and we had shipped everything that was asked of us. But there were a few minor flaws in the delivery, a few dings and bangs along the way. So as a result, after the initial release, the more features that we added, the slower the team moved. And not only did we move slower, but things started to increase in cost as we were adding more and more new stuff. We were getting slowed down, right? It's as if being held back by a parachute. And that parachute was technical debt. Except for we were building microservices, so it kind of looked like this, really. All right, so let's get a quick definition here. So technical debt is the gap between where your software system is today and where you need it to be to continue shipping value. All right, and just to kind of explore this idea real quick, if your architecture supports, some set of features A, your product owner comes in and says, hey, we need to be able to do these other types of things, features or qualities, or respond to the market in some way. B, basically what it takes for you to get from A to B is, your potential technical debt lies, and that's kind of where we want to focus. Technical debt, so it's a metaphor if we're talking about these technical trade-offs in the context of business goals, and from an architecture perspective, really what we're doing is putting quality attributes in tension with business value, continuing to ship. Okay, a couple of examples. Okay, if you want to ship this week, then we're going to have to hard code all the config options, right? Perhaps you've said something like that on your team. If you want all the features, maybe it'll only work for 100 users, right? Or perhaps if you just want something to be delivered, well, it might not be as fast as you want it. It'll be slow sometimes. From an architect's lens, when I look at these things, I see trade-offs between schedule and modifiability, or scope and scalability, straight up business goals and performance. And these are the types of trade-offs that we have to make every day to get stuff out the door. I love technical debt, okay? Absolutely love it. It drives my team crazy, but I'm all for taking on debt in the right ways. Chuck is nodding his head vigorously right now. He hates it when I do this. Technical debt, it's a natural byproduct of every successful software system. You really can't avoid it. So the real questions that we should be asking is not how to avoid the debt, but where is it? How bad is it? And what are you going to do about it? All right, and to try and work through some of those ideas, I started working with my team on this metaphor of a technical debt portfolio. All right, so the common idea that we use to introduce technical debt to people is to say, well, it's like buying a house, which, as it turns out, doesn't really work with the younger crowd these days because they just don't buy houses anymore. But it's like buying a house. Most of us can't pay cash up front. We take out a loan. You get the house today, and then over time, you kind of pay back your loan, right? Extending that metaphor differently, or thinking about a different perspective on areas where we get value for money, we could look at the stock market, looking at investment, okay? So typically what you would see with an investment portfolio is you'd want a nice blended portfolio to balance your returns and your risk, right? So you might have some set of stocks, which are high risk, high reward, but just in case that goes sideways, you also want to have some bonds and some cash on hand so that you are able to respond in case things are going wrong. We'd like to diversify our technical debt and be very strategic about what we're choosing to pay down as well. right, so we attempted a definition of this. I'm not saying it's a great definition, but effectively, we look at our debt portfolio as an architecture view that's combining this idea of potential technical debt with the probability of change, probability that we're going to have to act on that potential debt, really so that we can characterize costs and urgency of repayment. It's a bit of a mouthful. So the keys here are, this potential debt we see as kind of the interest rate, and then the probability of change is kind of our risk profile. Okay, and if we take these two ideas, we can kind of put it together to build out the portfolio. So if we start by measuring technical debt and creating a product roadmap of some kind, we can combine those things to create the portfolio, which we can then use to create a debt repayment plan. All right. For us, the way that we break this down is the architects or the developers are responsible for measuring the debt, and oftentimes creating it, but measuring it. The product owner is going to be responsible for creating that roadmap, right, deciding the strategic direction and the value that we're going to be targeting. We work together then to create the portfolio and decide what to do about it. Okay. Okay, the reason this works, so, or I guess some of the grounding principles that we kept in mind when we were building this thing out. We assume that there are debt indicators that are visible in the code, meaning that we can actually see the potential technical debt within our code base. That's very important for measurement. We also have to kind of accept this idea that debt is temporal and conditional, meaning it's not necessarily technical debt today, but it could be maybe next week or next month. And then we also have to deal with this idea that the interest rates are very contextual, meaning if we have to pivot, something that was very important this week, something that could have been considered, very deady code this week might turn out not to be important at all next week. To kind of drive these points home, let's see some more concrete examples about measurement and how we can kind of deal with it. So for building out our portfolio, we looked at four metrics. Conceptual design integrity, which I'm going to go into more detail in a minute. Code churn, which is basically how often we're touching different files or classes or microservices. General code quality, which would be things like defects per kloc or number of errors logged, things like that. Probably some of the more classic measures. And then we also took qualitative feedback from the team. Hey, Joe, what do you think are the worst areas? And then, see what kind of the consensus is going on across our system. Let's dive into this conceptual design integrity real quick. So we consider this, let's see, we looked at this as kind of a percentage of primary contributors, and what we were kind of looking for is one or a few minds kind of building a design together, okay? We made some simplifying assumptions so that we could measure this, and this is kind of important because you could poke holes in this if you really, really wanted. We were counting just pure commits into our Git repository. I think we filtered out the merge commits and things like that. But just counting the number of commits and who was making those commits. We actually found that this was a fantastic proxy and very easy to count. So it's not perfect, it's not precise, but it is a good indicator. All right, a good measure for this would be, maybe there's 1 to 3, so-called architects, kind of key influencers on the repository, and maybe a limited overall number. And then a bad measure it might be if there's no clear architect who's influencing this, or if there are many cooks in the kitchen. All right, let's take a look at some data here real quick. So microservices across the top, teammates, obviously names changed to protect the guilty on the sides here. You can pick out a couple of things right away that might be wrong within our system. So let's start with an easy one. Who are the likely architects of each one of these microservices? So looking at a number of code commits, we can see that there are some individuals who interact with the services orders of magnitude more than others. These are the key influencers, right? And what we wanted to look for were, 1, 2, maybe 3 people who were doing that. There's actually kind of a hidden problem here. Larry's on rotation. He's not actually on our team anymore. That's a huge problem for us. So that's something that we need to take into account as we're doing this analysis. All right, which services might have poor design integrity? This one also turns out to be pretty easy to notice. I don't know what was going on here, but everybody just seemed to have a whack at this service. I can tell you that was probably the worst code base we've seen, and I mean, you can just see it by these numbers. It's no surprise, really, in retrospect. From a metric perspective, we could also quantify this as a number. I don't know how useful this is, but if you need to be able to like show something very simple to a person, you could do that. So this is just simple division to get a percentage, and sure enough, the same services pop out using a metric instead of just kind of looking at the data itself, which is kind of cool. All right, so I'm not going to go any more into measurement. I am going to say that there are lots and lots of ways that you can measure. Our recommendation is to pick 3 or 4 things that seem to work for you and kind of use that as your guide, okay? Philosophically, what we were looking at was things that were simple, things that we could have available tools, such as counting commits in Git, right? We were looking for reliable indicators, not necessarily precise indicators. With this initial analysis, I think this macro resolution is very important. Okay, so we really wanted to see where were the problems, not necessarily what the problems were. The what part is going to come later. And then finally, we needed something that was simple to explain, both to our teammates, but also to management, our product owner, and other business stakeholders potentially. If you are looking for advice on measurement, I can recommend this book, Software Design X-Rays. There's numerous tools. SonarQube is probably the most famous one. I feel like there's also been talks so far at this conference on other measurement techniques. So do please seek those out. All right, so by the time we're done with this analysis, we could end up with a view that looks something like this. Just a basic heat map showing where kind of the key problem areas are. The more red or the darker the components, the poorer the quality or the greater the potential technical debt exists. All right, so now that we've identified our potential problem areas, let's try and figure out where the actual technical debt is and how to prioritize it. Okay, the truth about technical debt, all right? If you never touch the code, it doesn't matter. It's not technical debt, all right? I know that doesn't maybe resonate or feel good, but if you never have to touch the code, then it's not gonna hurt anybody. It really isn't. And this is kind of the core idea, the core concept for this portfolio. All right, let's apply that principle real quick. So if you look at this graph, if you look at this chart, you might be tempted to say that the worst offender is probably where we ought to dedicate our time, right? This is the poorest code, probably where we ought to do it. Make all of our changes. But what if I told you that according to our roadmap and our customer issues that we're hearing coming in from the field, that these components are actually where most of the changes are going to need to happen over the next, say, 3 to 6 months? That is really the place where we should be focusing our effort, not necessarily on the poorest quality. All right, so to kind of tease this information out, we created a workshop. It takes about an hour and a half to 2 hours to run, and we're going to walk through how that comes together. So let's see here. The goal of this workshop is to really is to prioritize your technical debt and then to come up with a strategy for how you're going to repay it. You're doing this in coordination with your product owner, your management, and your engineering team as well. Preparation-wise, you come into the meeting with a feature roadmap and some knowledge of your architecture, that analysis and the measurement that we were just talking about. And then materials, very simple. This is a whiteboard, markers, and sticky notes kind of thing, okay? All right, preparing the roadmap. So for us, we would take epics from our, the roadmap backlog that we have, and we would look out about 6 months into the future, about 2 quarters, which for us was about the degree of confidence that we had that there was a 50-50 shot we might actually do the thing that we were being asked to do. We move really fast, let's say, in our environment, where we can be changing very rapidly 1 month to the next. This is not the kind of thing maybe that you want to try and plan out for a year, but use that as your guide, I think. If there's like a 50% likelihood you're actually going to do the work, that's the time frame you should be thinking about. Yeah, and then working with your product owner. The product owner owns the roadmap, so this is something you have to collaborate with him on. For the architecture analysis, this is the measurement that we were just talking about. And really the important things you need to do before coming to the workshop is make sure that you can actually sketch the relevant views of your architecture and that you kind of know where those problem areas are. If you can't answer those questions, then you're not ready to start this workshop. All right, 5 steps here that we're going to do. So and we'll take these each in turn and kind of walk through some examples of how the workshop can come together. So first 2 steps, review the relevant architecture views and review the prioritized roadmap. So basically with this, when we ran this workshop, we got in the room and we sketched, you know, the key, this is the kind of key microservice view of our system that was relevant to this particular discussion. We walked through the components and made sure like everybody knew what was important or what all these different things meant, everyone that was participating. Our product owner did the same thing. So off to the side here, smudged out so you can't see it, is our roadmap. So just take my word for it, okay? Product owner did the same thing, kind of wrote the key items on the board, prioritized top to bottom, and then made sure that everybody understood what each item on the roadmap involved from a business goals perspective, right? Oh, right, so off to the side, you can't see it, but both of these things are actually visible in the room. Just, you know, cameras only show so much. Okay, so after you've done the introduction and kind of level set with everyone, the next step is to actually go through the prioritization exercise, through the combining those ideas, the exercise of combining those ideas. And to do this, what we're going to do is take each roadmap item, brainstorm likely solutions given your the current architecture. We're going to, for every component, we're going to add a sticky note to the whiteboard. If it is adding value, that is, if it is enabling one of your roadmap features, we're just going to bump it to the right a little bit to indicate that's giving more value. Let's see here, depending on the cost of change for that particular component, based on your measurements, based on your kind of knowledge about what's there, you would move it vertically. So things that are more difficult to change would go higher up. All right, so let's just walk through a quick example of what that looks like. So let's say we're going to look at roadmap feature number 1. And this could be anything from, I think we've had things like improve the performance of use case X to implement whole new feature, functional requirement kind of a thing. Okay, so let's say roadmap feature 1 is going to require that we manipulate 2 existing components, AA and BB. All right, so we would stick those on the whiteboard, and what this is telling us is that BB has a relatively low cost of change, while AA is the more costlier thing. Perhaps the quality is a lot worse. All right, so now we're going to look at roadmap feature number 2. When we do that, we see basically, let's see, we'd have to change AA to satisfy that use case, which means we move it to the right a little bit. We have just enabled 2 features, potentially 2 roadmap items, by improving that component. Meanwhile, CC is also required for enabling roadmap feature number 2, so it also goes on the board, except for, golly, it's way up there. It must be really, really bad, whatever's happening with that one. All right, finally, we'd look at a 3rd roadmap item, and you would see perhaps BB and CC would, BB, CC, AA would all need to be manipulated to do that one, so you see everything shift, and maybe it's more complexity to try to satisfy that, so we kind of move things around on the vertical axis as well a little bit. Cost of change is relative in this graph, so it's not necessarily a quantitative kind of idea, but what we want to do is have those conversations about, is it going to cost us more to fix or to improve CC over, say, BB component? All right, this is what it actually ends up looking like in practice. So as I said, simple sticky notes and whiteboard kind of activity. Okay, so last step is to prioritize the components that you have for repayment. This is basically looking at the amount of time that you're willing to put into tech debt repayment and then picking the best bang for your buck. That's really what this is all about. So if we look at that previous diagram, the things that are circled here are the ones that we chose as the top priority things. And you can see a couple of odd choices in here. This one down at the bottom, that is actually our number 1 priority, we were mandated to change that for a security reason. So we really didn't have a choice in that. It turned out to be an easy change, but it was something that we had to plan for. So we wanted to capture that idea in our portfolio so that we had a holistic understanding of where we were spending our time and costs. The other one up here that is kind of less value, we're looking out a little bit further, and we're partnering with another team to help us. So we're kind of looking maybe 2 steps ahead. From a pure kind of lean perspective, that might be wasteful, but that team happens to be experts in that area, so we would like to be able to leverage them now since they're available. Otherwise, it seems like clear and obvious choices. These are the things that enable the most value for us. We should start there. Note, as much as it would have felt good to change this thing that was the worst, that was not prioritized during this workshop. And it would feel so good to fix that component. It really would. All right, finally, there were a couple of other things that were down here. These are also enabling a lot of value, but the team felt, and based on our analysis, they're basically ready to go. There's really not that much work to do here. That doesn't mean there's no work. It's just that we don't need to start preparing early to be able to receive the next set of changes, okay? All right, I should mention this as well. So as we were walking through this exercise, it turns out there were additional concerns that were not necessarily architectural or captured in the current architecture. We jotted those off to the side for kind of further discussion. Seemed to work out pretty well doing that. All right, all told, we spent about 15 minutes or so reviewing and getting everyone level set to have this conversation. The actual brainstorming through the roadmap and kind of creating the portfolio ended up taking us about an hour or so. Obviously, that's going to vary based on how big your roadmap is and how many components are involved, how deep you want to go with this exercise. You can time box it to make sure that you only spend the amount of time that you want to on this exercise. And then the final prioritization took about, 15 minutes or so to talk through what we were going to do once we had a really good view of where our tech debt was and what kind of influence it was actually having on our roadmap. All right, so a couple of tips and hints here. You got to include your product managers in this. If they are not in the workshop, then you probably just shouldn't bother having it. You really need to have a diverse group of stakeholders to be able to walk through the business goals and kind of have those key trade-off conversations. We found it extremely helpful, and we continued to refer to both the architecture and the views that we had made and the roadmap itself, keeping those visible throughout the entire workshop. We put them on whiteboards. You could probably print them out on paper, and that would work well also. Computers, I don't know. I prefer kind of lower fidelity kind of interactions, but if you're a digital kind of office, that might work as well. Notes were absolutely critical, mostly so that we could have that trade-off discussion later. Which one of these changes would influence which roadmap item? So by the time we were finished with this workshop, we felt like we had a fairly strategic view on our technical debt, right? We understood where the common problems were. We had a very clear repayment plan, and we had, most importantly, a strong rationale for why that was the right plan for us. This is something that we could take to our product management, to our upper management, and justify our investments, right? Justify the things that we were investing in. Nice. Okay, and something that is occasionally confrontational when we have these tech debt discussions, we came out of this meeting, engineering and product management, we came out of this meeting unified in what our plan was. Which is just a really great feeling, knowing that we're on the same page and moving in the same direction with the same goals in mind. Okay, so based on our portfolio that we created and the analysis that we did, we had kind of three things that we did. We actually ended up defaulting on one service and just rewriting the whole thing, which was very painful but sometimes necessary as a last resort. We refactored our way out of two of the services that were on there, and then as we discussed before, we ended up accepting the debt that existed, or the potential debt that existed in many services, including our worst offenders. So those are things that will perhaps come up later. But the reason for that, there was no reason for us to be touching that code, so just let it sit. Oh, by the way, if you want to hear more about that experience, there's a talk this afternoon by some of my teammates here, these two gentlemen about architectural hoisting. So the refactoring, I think, led to significantly stronger code bases. We were also able to observe positive effects just by looking at how our errors were happening. So this was one of the things that this is the service that we defaulted on. The big purple spot there is the percentage of errors that week that were reported in our Kibana dashboard. After the refactor, or I guess after the rewrite, number of errors went down, and that is not because we stopped reporting errors, by the way. Like, we actually did it, as best that we can. What's interesting about this is we have kind of peeled back the onion, and now we have a new worst offender. So the journey continues, I guess. All right, quick caveat to kind of wrap this up here. The predicting and the estimating value and the likelihood of change, extremely difficult. This is not necessarily a hard science kind of activity, but it is important to go through that exercise of trying to measure and trying to estimate, okay? Probably the most important thing out of this is the conversations that you're gonna have. It gets you thinking more strategically about your debt and where you should really be spending your time. We found that it led to potentially counterintuitive kind of conclusions, which I think made the team much stronger and better able to respond. Another thing that we're asking ourselves recently, can we do better? In some ways, the tech debt portfolio is very responsive. Okay, we're currently looking at ways to perhaps adapt ADRs so that we can have a more strategic view before we get to this point of looking back. Perhaps having triggers for when we should initiate refactoring. And finally, we're looking at things for automatically generating and kind of observing these quality measures over time, something that would be fantastic to do. We just haven't gotten around to it yet. Yeah, so you can start creating your own tech debt portfolio as soon as you get home. You can measure debt. You don't need permission to do that. And then you can talk to your product owner about sharing the roadmap with you and kind of having that, starting that conversation. Very, very easy thing to start. And with that, thank you very much. I'm happy to answer any questions with whatever time we have left.